Anna Menzel. Welcome back to my channel. This was day 27 of the July LeetCode or the JuleetCode challenge while I was out of town, while I was doing the last couple of days or the last week and a half of the JuleetCode challenge. I do want to go over my solutions. So day 27 was question number 2141, maximum running time of n computers. This one was labeled hard, and it was very much so very hard. So my submission, let's show you this, was really bad, worse than the last one. So while I don't necessarily recommend this solution, I'm going to go through my logic and what I decided to do anyway. But I do in the future want to redo this so it at least hits 50% of the runtime and 50% of the memory. But I would love to see if you guys have a better solution for this later on. And if you do, please feel free to comment it or, comment on my GitHub that I have these solutions in. So let's go through this question. So you have n computers. You are given the integer n and a zero-indexed integer array batteries, where the ith battery can run a computer for batteries I minutes. You are interested in running all n computers simultaneously using the given batteries. Initially, you can insert at most one battery into each computer. After that, and at any integer time moment, you can remove a battery from a computer and insert another battery any number of times. The inserted battery can be totally new battery or battery from another computer. You may assume that removing and inserting process takes no time. Note that the batteries cannot be recharged. Return the maximum number of minutes you can run all n computers simultaneously. And then they give you this really awesome visual example down here, which to me really helped me kind of work through this problem, because the explanation really didn't help me too much. And these are the constraints. So I do want to go through the solution. This is the part of the solution that starts the problem. So when you get onto this questions page, I don't necessarily think we have to go through that now, but I do want to start into this helper function that I have that can run all computers, and that basically just checks whether the computers can run for a given runtime by comparing the cumulative battery capacities with the total required capacity. So that would be this n times runtime, and that iterates through each battery capacity in batteries and then adds the minimum of the current battery capacity and the given runtime and the count. And if the count is greater than or equal to the required total capacity, it then returns true. Otherwise, it returns false. So that's this. So this area right here, it initializes two variables, left and right. Left starts at 1 and right is set to the sum of the battery capacities in the batteries list. So this basically sets the range for the binary search that we do down here. We use this binary search loop to find the maximum runtime that allows all the computers to run, and calculates the middle point or the mid between left and right. So it'll call the can run all computers function with mid to check if all the computers can run for that time. And if they can, it updates the left bound to mid. Otherwise, it updates this right bound to mid -1. So then after the binary search loop completes, the method returns a value of left, which represents the maximum runtime that allows all the computers to run. So I utilized a binary search approach to this. I do believe that there's another or a better way to do it. I still haven't read the editorial for this. I should have. But basically, I just wanted to try to find the maximum runtime of the computers with the battery capacity. So that is the logic behind my solution. And again, My solution is a far cry from being fantastic, but it is a solution nonetheless, which I do want to be clear is sometimes better than no solution. But again, I will be redoing this at a later date. I am actually kind of excited to tackle these and a couple others because I feel like now I've really kind of put myself in a better mindset in terms of like doing logistics and like solving something logistically, and streamlining it so we can improve it altogether. So thank you guys so much for watching. I will leave the GitHub repo with all the LeetCode solutions I've ever done in the video description down below. You guys are more than welcome to fork and clone, make it better. I don't know if you can make this one worse, but learn something, do something new, have fun doing it. And I will see you guys in the next video. Thank you guys so much for watching. Goodbye.